event today at KCD Hyderabad, and I know we all are hungry, but won't be taking a lot of your time today. So today we are talking about how you will manage Kubernetes in an air-gapped environment. So air-gapped might be a new word for many of you, and some of you might be already knowing about air-gapped. So don't worry, we'll be covering it from the basic and learn what is air-gapped and how Kubernetes is managed in an air-gapped environment.
This will be the agenda for today's session. We'll first understand what is air-gapped, then we'll look how air-gapped is integrated in Kubernetes. We'll look at the key characteristics and applications of air-gapped, how we can create an air-gapped environment, the benefits, challenges and applications of air-gapped environments. At last, we'll conclude our session by discussing the effective cluster monitoring, how we can manage software updates securely, and a Q&A session. I'll introduce myself. My name is Unnati. I work as an MPS2 at VMware.com. I work in the Kubernetes Grid release engineering team as a release engineer.
Hi, myself Akshat. I work as a founding software engineer at Astro.ai, where we are building cloud cost platform, how you can save your cloud cost using AI. So let's get started. So do you know that in the world, every 39 seconds, all the organizations are getting impacted every 39 seconds by these cyber threats and the cyber attacks. In a minute, there are countless organizations which are getting affected by these cyber attacks. And even now when we are talking, there are many cyber attacks which are happening and companies are having huge loss because of that. So security is a major concern here when we talk about air-gapped. So this, because of security only, the concept of air-gapped came into the picture.
Let's dive into the main topic of our talk. What is air-gapped? Air-gapped means the highly secure computer setting. You can imagine it as an isolated island where there is no internet connectivity or no network from the outside world, and the only thing present is air. The internet connectivity is restricted in an air-gapped environment. Cluster can only connect to the software hub or the registry by specific proxy rules. There are no Docker hub or any other artifact stored, so that the internet connectivity is restricted. We only have a restricted set of commands available. Only specific technical user, not a root user, has the access on the OS. This reduces the risk of cyber attacks, unauthorized access, and the data breaches. In this diagram, you can see the exposed network has the internet connectivity and the air-gapped network is not having any internet connectivity. It has restricted internet access.
Now we saw the basic terminology, what air-gapped means. Now let's understand how air-gapped is important in a Kubernetes cluster and how is it implemented. So this is a typical Kubernetes cluster that we have with the master node and the worker nodes. So in a master node, you have certain components like API server, scheduler, HCD, and the controller manager, which is the main brain of the Kubernetes. Also, you have worker node. In the worker node is the node where your exact application will run inside the pod, and the Kubernetes is responsible for the lifecycle management of your application and the pod. There are certain other components as well. So the main thing to note in this architecture is the Kubernetes cluster is we have set up the firewall proxy so that there is no connection to the internet, and it has only certain amount of permissions or the resources that can be accessed. So there is a proxy firewall that is set up which acts as a firewall between the internet and the Kubernetes cluster. So this cluster is only available inside your protected network or the internal network that you have.
We'll look at some key characteristics of air-gapped environments. First is physical isolation. As we have already told, the air-gapped environment is an internet-restricted environment. So everything is physically isolated. We can also set up network hardware like root, routers, switches, so that every inbound and outgoing traffic is protected. Second is controlled access. We can set up authorized access to only few users so that the network is protected and only some people have access to that environment. We can do it by rollback access control and multi-factor authentication. compliance. These are a set of rules and regulations used by the organizations so that their data is protected. Data confidentiality. By adhering to the regulatory compliance, we ensure that the data is confidential. Let's see some of the applications of air-gapped environments. There are many applications of air-gapped environments, but these are few of them. Government and military. These organizations have highly critical and sensitive data that needs to be protected so that we are not having any national security threat. Healthcare and finance. In the healthcare industry, we need to safeguard patients' records like diseases, the blood reports, and the illness, because it is a personal data that cannot be leaked. Next is financial sector. In the financial sector, we have the list of transactions done by the banks, their debit card number, PAN card number, the PINs, passwords that need to be protected every time. Critical infrastructure. There are many ongoing government projects like water supply, setting up power grids, and these systems are essential to be protected by the cyber threats.
Now, since we learned about the basics of air-gap and applications of air-gap and saw which industries are using it, now let's see air-gap, how Kubernetes is deployed and what changes do you need to make in your Kubernetes cluster so that it works in an air-gapped environment. First of all, you need to control your sources where it is. So you need to integrate the local artifact store. So you need to use JFrog, or if you are only using OCI images, you can use Harbor. And you need to include this in your enterprise architecture on-prem. And then you need to keep in-house code in a centralized location. You can self-host your Git repositories, and you can use that centralized location for storing your code. You need to also do vulnerability scans on regular basis so that you prevent from the threats based on dependency. And also you need to have a regular upgrade procedure as well. Next comes is the what changes you need to make while you are provisioning the cluster, like what bootstrap changes you have to do. So you need to direct all the resources which are used in the Kubernetes cluster to the artifact store, central artifact store that is stored on-prem. And also you need to do some initial changes in the Terraform or remote execution of the code if you are commands if you are doing that. You need to make changes in the cloud init file. So cluster API, if you know about cluster API, so it is used for doing a lifecycle management of your cluster using the API. So cluster API has machine controller, and machine controller has the knowledge to talk to the cluster API providers. So cluster API providers can provision the nodes, and the cloud init file is used in that. So you can do those changes using the pre and post KubeVDM hooks. So this is the simple architecture like what I just explained just now. So this is the architecture about that. So you have your template with OS and other CNI options there, and you just provision this template to your Kubernetes cluster where all the dependencies are used at either by your Kubernetes cluster or your application. Let's talk about this, how a air-gapped Kubernetes architecture look like. So here you can see the artifact store is firewalled, and also down the Kubernetes cluster is also firewalled. So Kubernetes cluster doesn't have access to the internet or any other resources which is outside the network. So this can be part of your CI/CD process where you build the images, binaries, and ship them to the Artifactory store. So only the CI/CD pipeline has the access to this Artifactory store, which is in the middle. So this Artifactory stores has your YUM packages that might be required for your application, binaries, OCI images, and all those stuff. And this Kubernetes cluster has only access to this Artifactory store in the middle. And you need to also do the vulnerability scans and alerting on this Artifactory store so that there is no malwares or any infected virus files present there. So your Kubernetes cluster can only access this Artifactory store and nothing outside. So this is how we can achieve air-gapped in a Kubernetes architecture. Okay, we'll go next and try to understand the benefits.
We'll see the benefits of air-gapped environments. First is isolation from external threats. As we have air-gapped environment, that means we have disconnected the network. Our system will be isolated and it will be protected from external threats. Data confidentiality and integrity is helpful in prevention of data leakage. Regulatory compliance, as I have already told, these are the set of rules and regulations that are followed by the organization to protect their data. Controlled update and patch management. As we are not connected to internet, we have to do everything manually. So this will help us in managing the updates and patch management securely. Increase trust and confidence and protection of intellectual property. So the organizations that are using the air-gapped method to protect their data have increased trust and confidence on the organization who are doing the air-gap of their product. We look at the challenges that we are facing in using an air-gap environment in Kubernetes. First is manual updates. Because we don't have any dependency on the outside network, we have to do everything manually. This is a very cumbersome process because it will rely on a physical device and a secure transfer method to do the manual updates, which can be time consuming and error prone. Image building and distribution. We can face challenges in building, testing and distribution of the image in the form of container images without internet access. And next is security awareness. It's not 100% sure that by using air-gapped environment we are protecting our data because there can be insiders who can pose threat. Suppose Akshat is having the access of the authorized person to access the air-gapped environment and he only injects some malware in the system. So we are not 100% sure that our data is protected all the time. Local registries. As he has already told, we need to set up a private or local registries by which we can push and pull the data. Backup management. We need to ensure that we have a backup plan ready for rolling back the data that we have lost in any disaster or without the external connectivity. Hardware and infrastructure. Setting up an air-gapped environment involves setting up an external hardware device so that our system runs on that. This is very time-consuming and also cost-consuming. We'll look at the pros and cons of using air-gap. It prevents downloading malicious data. As I am telling from the beginning that we don't have internet connectivity, so we have very less chances of getting any malicious data that is affecting our system. Air-gap reduces the chances of hacks from outside. The con is it increases the efforts cost of implementation and maintenance because we have to set up a physical hardware or in any physical device to manage and implement the air-gap concept. It doesn't ensure 100% security. Now we look how we can manage the software update securely. Setting up a local repository by mirroring the external repository and using it as a local repository. Secure transfer methods by using a physical media like USB drive and secure transfer methods like checksum verification by verifying the SHA so that we can cross-check whether the things that we have uploaded or the packages that we have uploaded are correct or not. Manual update process. To be up to date with the updates that are present in the internet environment, we can set up scheduled updates in our air-gapped environments so that we are always up to date with the software that we are developing and we are not prone to any vulnerabilities. Digital signatures and authentication. We should always ensure that our signatures, we are having digitally signed packages and all the certificates are valid.
So as we saw that updating softwares are really important and the application that we are running in the cluster. So we should have a good backup and rollback strategy. So if you are updating your application which is running inside the cluster, runs into a problem, and you should have a proper rollback strategy so that you can bring back the cluster to its original state. So that's very important. The next thing is the security measures. So you should always check and keep a regular check of access control. The people who have access to your system, so you should do a regular check of that, and intrusion detection is definitely very important. Next and the foremost is the compliance verification. So you should have a checklist of all the verifications that are to be done at the time of the upgrade, software upgrade that you are doing. So it should pass all the vulnerability checks and the security checks, and you should always have a detailed documentation of what has changed in the latest release. Next and very important thing is cluster monitoring. So monitoring always plays a very important role in Kubernetes or any kind of infra that you are using. So in airgapped Kubernetes or airgapped environment if you are using, so what you can do is you can set up your elastic stack locally and use them as a monitor. You can use any custom metrics exporter like Kubernetes or any others to collect the matrices and exporter of your cluster or any of the workload that you are running in your airgapped environment. Next thing is the local storage that can be done using the persistent storage and the data retention policies that you have set up in your environment.
You can also set up an alerting and logging for event monitoring in a centralized way. So that everything is centralized and you are monitoring at one place, not different systems, so that everything is in a centralized way. You can also use Grafana for that. Then that's all for this session. Thank you very much for your patience and attending the session. We are open to any questions and we can connect afterwards. These are our socials.
Thank you very much, and these are our socials. You can connect with us, and if you have any questions, do reach out to us. We would be happy to answer those. Thank you very much.